which statement about these functions is true. So you have two different functions. You have the function g of x given by the equation and the function n of x given by the table. So what you want to do is you want to go through each choice and try each one out. So choice 1 is over the interval -1 to 1, the average rate of change for n of x is less than for g. So average rate of change, we need to calculate the slope between points with x values of -1 and 1 for both functions. So for g of x, what I would have to do is I would have to plug -1 into my function. So -1 squared minus -1 plus 6 to get the y value that corresponds. So again, -1 squared is 1 plus 6. So that would give me 6. And then I would plug 1 in to that same function. So -1 squared minus 1 plus 6. That's going to give me -1 minus 1 plus 6, which is -2 plus 6, which is 4. So now I'm going to find the slope between those 2 points. So 4 minus 6 divided by 1 minus -2 over 2. So the slope there is -1. Now I'm going to find the slope for n of x between points with x values of 1 and -1. So here are my 2 points there. 1, 9 and -1. So I find the slope is 5 minus 9 divided by -1 minus, so I get -4 over -2, which is 2. So is it true that the slope for n of x, which is this one, is less than the slope for g of x? Well, that's not true because 2 is bigger than the slope of -1. So now I'm going to go on to trace 2. The y-intercept of g of x is greater than the y-intercept for n of x. So this question requires a lot of work, even though it's just a multiple choice. So n of x, I can see the y-intercept right away. It would be 0, 8. For g of x, to find the y-intercept, that's when your x value is 0. So if I plug 0 into the function, I will get back the y value. The y-intercept is 0, 6. So is the y-intercept of g of x greater than n of x? Well, no, because g of x is 0, 6, and n of x is 0, 8. So that's not true. The function g of x has a greater maximum than n of x. So if I look at the table for n of x, I can see where the maximum is by following the pattern. So when I look at the pattern, I should see that the maximum point is 1, 9, so the maximum value would be that. For g of x, I can algebraically find that using my axis symmetry formula, x equals -b over 2a, so x equals -b over 2 times a. So that gives me 1 over -2, or -1/2. And then I'm going to plug -1/2 in to get my y value. You can use your calculator if you want to, so -1 squared is 1, 2 squared is 4, so -1/4 plus 1/2 plus 6. So -1/4 plus 1/2 is 1/4. So 1/4 plus 6 is 6 1/4, or 6.25. So for g of x, my maximum point would be -45, comma 6.25, and my maximum value is 6.25. So does g of x have a greater maximum? Is 6.25 greater than 9? No. Now I'm going to look at choice 4. I know it must be choice 4 because that's my last choice, but let's just make sure. The sum of the roots of n of x is greater than the sum of the roots for g of x. Okay, so roots are where your y value is equal to 0. So here are my 2 roots. They said 0, so I'm going to add them together. So -2 plus 4, that gives me a 2. To quickly find the roots of g of x, I'm going to go to my calculator, I'm going to go to y equals, and I'm going to type the equation in. So if I did that, and I looked at the graph to see where the parabola was crossing the x-axis, I could quickly find the roots. So here's my graph, g of x. My roots are x equals -3 and x equals 2. So if I added them together, I would get -1. So the sum of the roots of n of x was 2, and the sum of the roots of g of x was -1. So this choice is true. The sum of the roots of n of x is greater than the sum of the roots of g of x. Taking a look at question 2, we want to know how to compare the graph of f of x to the graph of g of x. So you could also, if you wanted to, you could take these into your calculator and use that to help you. So in y equals, I would first type in your parent function, which is g of x, which is x squared. And then next, I would type in your function f of x, which is 1/2 times the quantity of x minus 3 squared plus 1. Now you want to compare the two. So I looked at my graph. This is my graph of f of x, g of x, function. And this is my graph of f of x. So I want to know when I start with g of x and go to f of x, what happens. So you can see that f of x is definitely y, because the coefficient is a value between 0 and 1. So I can get rid of choices 2 and 3. I also know that the vertex has been moved 3 to the right and up 1. So the correct answer should be choice 1. Question 3. We're given the graph f of x, and we want to know which function represents g of x. And this time, our translation is written in function notation. Okay, so you have to know this negative out here means a reflection x-axis, and this value means vertical shift down 3. So the graph that would match that would be choice. Taking a look at question 4, zeros. Zeros means when your y value is 0. So we're replacing f of x with 0. So 0 equals 2x squared minus 4x minus 6. And you could try each choice, see which one works, and that it would be choice 2. Or you could algebraically solve. So if you algebraically solve, the first thing I would do would be to divide everything through by 2. Just to make it easier to solve. So 0 equals x squared minus 2x minus 4. And then what I want to see if I can factor this. So I'm looking for factors that multiply to -3 and add to -2. So that would be x minus 3, x plus 1. So now when I solve, I should get the answers of x equals 3 and x equals -1. That would be choice 2. Okay, question 5 is asking us to find a realistic domain for the function. The first thing we want to really think about here is that we're talking about a function that's representing h of t, which is showing height of our ball in feet after t seconds. So the y-axis is representing the height, h of t, and the x-axis is representing our time in seconds. So it doesn't make sense realistically to have any kind of negative time or negative height. So if you look over here, anything to the left of the y-axis would be showing that our time is negative. And anything that goes below the x-axis would be representing negative height. So really, I want to show this y-intercept would be like my starting value of my graph. And my x-intercept over here would be the final value. So this is really the piece of the graph that we're talking about in terms of our realistic domain. So domain, again, represents our x values. So my starting x value would be 0, and it would go all the way until 5. So from 0 to 5 is a realistic domain for this real-world problem. Question 6 is asking us to determine the greatest average rate of change. So they're giving us 4 choices. So the first choice is from 0 to 1 hours. So from 0 to 1 hours, if we look on the graph, this is my point for 0, it's 0, 200,
and my point for 1 is 1 comma 700. So average rate of change, I'm going to try to find the slope now between those 2 points. So 700 minus 200 over 1 minus 0 gives me an average rate of change of 500. Okay, so now I'm going to go to choice 2, between 1 and 1.5 hours. So between 1 to 1.5 hours. Then I'm going to look at my grid. So 1 I already know is 1 comma 700. 1.5 is 1.5 comma 900. So if I find the average rate of change, 900 minus 700 over 1.5 minus 1, it's going to give me an average rate of change of 400. All right, on to choice 3, which is 2.5 hours to 5 hours. So 2.5 hours is 2.5 comma 1500, and 5 hours is 0.5 comma 1640. So if I find the average rate of change between those 2 points, I would be 1640 minus 1300, and dividing that by 5 minus 2.5, that's going to give me an average rate of change of 136. And the last choice, once it's to find the average rate of change between 5 and 8, so 5 is 5 comma 1640, and 8 is 8 comma 1800. So let's write that down here. From 5 to 8 hours, I would be finding the average rate of change by taking 1800 and subtracting 1640, and dividing that by 8 minus 5. And that's going to give me an average rate of change of about 53.3. The 3 is repeating, so you can indicate that with that line. So now I want the greatest average rate of change, which we can see here is happening between the 0 to 1 hour time. Okay, question 7. We're being given this formula, I equals PRT, and they want us to find the new formula and figure out what R equals. So we want to solve for R. So right now, R is being multiplied by both P and T. So in order to get R isolated, I can divide by PT on both sides of my equation, leaving me with R is equal to I divided by PT, which is choice 3. Question 8 is asking us to find the pair of equations here that could not be used to solve this system of equations for x and y. So if you take a look at each choice, choice 1, the top equation matches our original, but the bottom equation would match if we had multiplied the original through by -1. So that could be used to solve. So that would not be our choice. Choice 2, again, the top equation matches up, but they did alter the bottom equation by multiplying through by a positive 2 to get the -4x plus 4y equals -16. So that also could be used to solve. Choice 3, the top equation, if you look, we went from 4x plus 2y equals 22 to 12x plus 6y equals 66. So that happened by taking our first equation and multiplying through by 3, and the bottom equation would match up if you multiplied through the second equation by a -3. So again, that could be used. So we know our choice is 4, but let's see why. Choice 4, the first equation could be found by taking the top equation, original equation, and multiplying through by 2. Now, at first glance, it looks like they tried to multiply the bottom equation by positive 4. The -8x is multiplied by positive 4, the 8y, but the -8 is incorrect. That would have been a -32 if they had correctly multiplied through by 4. And question 9 is asking us which expression is representing in a result of an irrational number. So once you perform the operation, which answer would be irrational? Well, for I, if you added these up, you could do this in your calculator, you're going to get -1/40. That's a fraction of integers, so that is rational. Choice 3, rad 5 times rad 5 would give you radical 25, which if you type this into your calculator, you would get +5. That's an integer, that is rational. Choice 4, 3 times the square root of 49. Well, 49 is a perfect square, so that comes out to be 7, and 3 times 7 is 21. Also a rational number. So if I take a look at 2, 1/2 plus the square root of 2. Well, the square root of 2 is an irrational number. 1/2 happens to be a rational number. Anytime you add a rational and an irrational number, your solution, your sum, will be irrational. So the only one here that would result in something irrational is choice 2.
Taking a look at question 10. I want to write the inequality that matches this graph. So the first thing I'm going to do is locate the y-intercept, which is right here, which is -3. That's my b value, and y equals mx plus b. And then I'm going to find my slope, which would be up to right, up to right. So my m value would be +2. So when I think about writing an equation, a line, it's y equals mx plus b. So if I were just writing the equation of this line, it would be y equals 2x plus 3. But I have an inequality here, so I need to represent my solution set. So in order to figure out which way the inequality sum goes, I have to use the two. So it could be that answer, or it could be that answer. So right away, I can eliminate choices 3 and 4 because the slope and the y-intercept are switched. So I'm going to pick a test point in the shaded section, 0, 0. And I'm going to test it in both inequalities. I want to pick the inequality where 0, 0 works because it's in the shaded section. So if I plugged it into this first inequality, we get 0 is less than or equal to 3, which is true. So that should be, what am I saying? 0. Let's plug into this one. 0 is greater than or equal to 3. And that's false. So my choice should be choice 1. I should be choice 2. What did I do wrong? I want 0, 0 to work. So I should be picking the choice where 0, 0 is true. I'm sorry guys, now I see why I was confused. When I copied my y-intercept value, it should have been -3, not a +3. So when I go to check, this should have said 0 is less than or equal to 2 times -3, and the 0 less than or equal to -3. And then when I went on this one, I again copied my y-intercept wrong. So that should have been -3. So with 0 greater than or equal to -3, that would have been true. So the correct choice here is choice 2. Taking a look at question 11. Right now we have this parabola, f(x) equals x squared plus 4x minus 3, and its vertex has the coordinates -2, -7. And if I wanted to, I could plot the other points on this parabola f(x), but I don't really need to. Because all I want to do is find the coordinates of the vertex of the parabola h of x. And they give me the transformation rule here. This is saying that in order to find the vertex of h of x, I have to take the vertex of f of x and move to the right 1 unit. So if I do that, I would be over here, and the coordinates of the vertex of h of x would be -1 and -7. So the first thing I had to do was state the coordinates of h of x. So I'm going to of the vertex. So I'm going to say that's -1, -7, and then I had to explain why. So I said to find the vertex of h of x, take the vertex f of x and move point 1 unit to the right. Taking a look at question 12, you're asked how many real solutions a quadratic equation has. You want to use the discriminant to figure that out, which is b squared minus 4ac. So my a value is 5, my b value is -2, and my c value is 1. So when I plug into this expression, I get 4 minus 20, which is -16. If your discriminant is negative, that means you have 0 real roots. Another way you could have looked at this would be graphically. So if you went to your calculator and you went to y equals, and you typed in this equation and looked at the picture, you want to look to see how many times the graph crossed the x-axis or touched it. So go to y equals, type in 5x squared minus 2x plus 1, and then look at the graph. I'll be able to see that it doesn't intersect. I'll show you a picture of that. 1 second. Here's my equation. Notice it doesn't cross the x-axis. And also, if you had drawn this picture in as a sketch, it said because it doesn't cross the x-axis, there are 0 real roots, that would have been perfectly fine as another approach to that problem. Question 13. You had to find the number of seconds it takes to achieve its maximum height, not its maximum height. Okay? So your seconds in this question represented by your time, so that's your x value. So what you would have to do would be to find the x-axis symmetry, which is normally x equals negative b over 2a, but because your x value is t, it's t equals negative b over 2. So my a is negative 16, my b is 64. So t equals negative 64 over 2 times negative 16. So t is negative 64 over negative 32, which would give you 2 seconds. Now we get to state the time interval when the height decreases. Okay, so we know this parabola, when we look at it, is reflected over the x-axis. We know that because of this negative right here. So we know our parabola opens down. We also know our axis of symmetry is x equals 2. So we know now that right here, this has a time of 2. So we want to know when our height decreases. So it's going to start decreasing here at 2. It's going to decrease until we hit the ground. So we have to find the point when we hit the ground. So the easiest way to do that is to type this equation into your calculator and look at the table. So if I went to my calculator and I typed in negative 16x squared plus 64x plus 80. I'm using x because we always need to use x as a calculator, even if the variable is a different letter in your question. When you looked at the table, you're going to say, okay, well, I know at 2 seconds here, this is when my parabola is going to start to go down after 2 seconds. Here would be when it hits the ground. So it's really going to decrease after 2 seconds, and then up until it hits the ground, which would be 5 seconds. So if you had this table to support your work, you could say the height of the object decreases from the time
For question 14, we're given a function and we're asked to state whether the vertex represents a maximum or minimum and to explain why. So in order to determine this, you need to look at your leading coefficient. The leading coefficient is negative. That means that our parabola would be downward facing. If our parabola is downward facing, that means it's going to have a highest point, which means it's going to have a maximum. So I need to first state that. So I'm going to state maximum, and then I need to explain why. So your explanation could just say the coefficient of x squared, or you could say the leading coefficient, but you have to indicate leading for that it's the coefficient of x squared is negative. So the parabola opens downward. this question then asks you to rewrite f of x in vertex form by using the completing the square method. Okay, so I'm just going to rewrite my function down here. And the first step when we're going into vertex form, when we're using completing the square, is to make sure that the leading coefficient is positive 1. So I know that it's not positive 1 because we knew up above that it was negative, which led to our maximum. So my first step here is going to divide every term by negative 1. So I get negative f of x is equal to positive x squared plus 14x plus 59. Second step is going to be to subtract my constant on both sides of my equation. So I have negative f of x minus 59. I'm going to save myself one extra step of writing by putting my open boxes here to get ready for my next step. Okay, so I divided through by a, I moved the constant over. Now what I need to do is focus on b, and I'm going to take the b value, divide it by 2, and square it. So I get 7 when I divide 14 by 2, and 7 squared is going to give me 49. So I'm adding a positive 49 to both sides of my equation. On the left side of the equation now, negative 59 plus 49 is going to give me negative 10. And on the right side of my equation, I'm looking to see what multiplies to 49 and adds to 14. That's going to be a positive 7. And since it's x plus 7 times x plus 7, I'm going to write that as x plus 7 squared. Now I'm going to add my constant back over. So I get negative f of x is equal to x plus 7 squared plus 10. But I want to know what f of x is equal to. So I need to divide everything through by negative 1 again. Now, when I divide x plus 7 squared by negative 1, I'm dividing the coefficient of positive 1. So that just becomes the coefficient of negative 1, and then minus 10. Okay, and for the last question, I brought over my table of values so I could start graphing these. We're being given two functions. One is r of x, which represents our revenue, and one is represented as c of x, which is showing our cost. So first thing was to graph the revenue and cost functions on the set of axes that were provided. So I'm going to look at r of x, and I'm going to just plot the points from 0 to 6, since that is how much of my graph is labeled by on my x-axis. So my first point would be 0, 0. Second point here is 1, 250. So moving over to 1, up to 250 on the y. Second point, 2, 400. So I'm over here at 2, going up to 400. 3, 450 would get me up to this point. 4, 400. 5, 250. And 6, 0. So this is the graph. This is my quadratic. Sketch here, make sure it's a curve. I'm going to label this as r of x. The color for c of x. Okay, so now we're going to graph c of x also from 0 to 6. So the first point here is 0, 600 would be my y-intercept. So I have the point 1, 550. 2, 500. 3, 450. 4, 400. 5, 350. And 6, 300. Okay, so this is my C of X. Okay, so once they are both graphed, and if you would put an arrow here, just because our grid is continuing and it wouldn't get negative right away, or you could have left the arrow off and just gone to the end of your grid. Okay, so our next part here is to determine if the company is going to break even and where. So it tells us here that the company breaks even when revenue is equal to cost. So using our graph, determine and state all values of x for which r of x equals c of x. Well, I can see that they are intersecting here and here. So x values, I now have to focus on the fact that my x values are number of tickets sold in hundreds. So this would be, they are equal at an x value of 300 and an x value of 400. And the last piece here is now saying profit is my difference between revenue and cost. So profit is r of x minus c of x. So they want to know if the group sells 500 tickets, will they make a profit? So I'm going to use my graph. At 500 tickets, which would be right here, my revenue minus my cost would come out to be 250 minus 350, okay? Which means I'm going to have a negative number. I'm going to have negative 100. So that would mean no, I do not have a profit. So I have to indicate no, and my work here is my justification.